Good morning, everyone. We are going to go ahead and get started here on our notes for 5.3. So we've already done solving these systems by graphing. We've done solving by substitution. Now we are moving right along. We're going to solve these by elimination. So this is the final method that we're going to learn. I would say most people find this to be the easiest method. That's why we kind of did our quiz. We did a quiz on just graphing and substitution. If you haven't done that, you might want to pop in and get that done. And then normally you can see here that it says day 1. I normally will break this lesson into day 1 and day 2, but just the way the schedule has been working out this week, I'm just going to do one long video and one long homework assignment. You can break it up however makes sense for you this week. If you want to do it on your distance day and then on Friday, if you just want to have everything done on Friday. I know that everyone's schedule, we're trying to get back into the swing of things with hybrid. So whatever makes sense to you, I'm just going to have, this is why this video might be a little bit longer than normal and the assignment might be a little bit longer than normal. We're pretty much doing 2 days worth of notes and assignments, but you can break it up however makes sense for you this week. All right, we'll get back kind of into a more normal routine starting Monday of next week when we can kind of get on a better schedule. All right, so we have elimination, right? We're solving these linear systems. So again, just as a reminder, when you solve a linear system, your answer should be an ordered pair, okay? You can't just end up with x equals 7 and call it a day, all right? You've got to have, well, I guess if I was going to give a better example, that's y equals 7, all right? But you have to make sure you have an x value and a y value. Once we come up with an x value, we always want to plug it into our equation, or a y value, we want to plug it into our equation, find the opposite. Right. So this is the easiest version right here when we already have opposite coefficients. Okay, because what we're doing with elimination is we are basically using these two equations as like a giant addition problem. And we're going term by term and combining these like terms as we go. So this is the easiest possible setup because we can kind of look ahead and see, oh, I've got a positive 5y and a negative 5y. I know those are going to cancel out to 0. That's what we're always looking to do. Later on with some other examples, I'm going to show you where you have to multiply an equation to get this elimination to work. But best case scenario, it's already set up. You don't have to multiply anything. So let me show you what I mean. Okay, you're taking these two equations and you're combining all your like terms. You're basically turning it into one equation. So my x terms, I'm going to combine 2x plus 6x. I'm going to get 8x, 5y minus 5y. I could call that 0y. You don't have to write the term that's getting eliminated. I could just put basically a blank here. That's how some people like to do it. I like to write out the 0y just so I don't trip myself up. Okay, but either way is fine with me. Okay, so I'll call that 0y. Okay, 17 minus 9, I end up with 8. All right, I can go through and say, okay, 0y, that cancels out. I don't leave 0y here in my equation. Okay, so I like to just rewrite it without my 0y, 0x, whatever term I'm canceling. So I get 8x is equal to 8. Should be pretty easy to solve from here. So I'm multiplying by 8, so I want to divide. Okay, so that cancels out. I'm left with x is equal to 1. And again, we don't say, oh, x equals 1, I've got my answer. We want to plug that x equals 1 into one of these two equations to get our y value. So we're halfway there with x equals 1. I'm just going to randomly pick an equation. It doesn't matter which one. I'm going to plug it into my 2x plus 5y equals 17. Okay, so I'm going to pop out that x and replace it with 1. Oh, I wrote an equal sign instead of a plus sign there. That would have messed me up. Okay, plus 5y. So 2 times 1 is 2. Plus 5y equals 17. Now I just have a two-step equation. All right, I want to get rid of my 2 first. I'm going to subtract it from both sides. So I get 5y is equal to 15. And now I'm multiplying so I can divide by 5 and divide by 5. All right, so cancel that out. And I get y is equal to 15 divided by 5. Y is equal to 3. Okay, so when I write my final answer, I want to have it in that XY, that ordered pair format. So X first, then Y. I'm going to have 1, 3 as my final answer. Okay, so essentially what we're doing with elimination, we're combining. Okay, we're combining our equations together to get rid of a variable. Okay, this doesn't work if after I add my equations together, I still have a y term. This works because I was able to get rid of that 0y. I was able to eliminate it. All right. So some of these we're going to have to do a couple more steps. So let me show you an example where it's not just perfectly set up. All right. This one is already set up the way I would need it to be. Okay. Negative 3x, positive 3x. If I added those equations together, those two things would cancel out. But let's look at an example, okay, when I don't have opposite coefficients. So, sorry, I have a window that popped up and now I need it to go away. You guys probably can't even see it because I'm just recording the one tab. There we go. So I've got these equations here where if I just added them together, I would just end up with another equation that I can't solve. I need equations to cancel out. Good, yes, it keeps popping up. I need equations to cancel out, or I need variables to cancel out if I'm going to solve by elimination. So what I'm going to do here is I'm going to look and see what the easiest one, okay, I can't really multiply 7 by anything that is going to make it easy to cancel out with 5. So what I'm going to do instead is I'm going to notice that, okay, this 2y over here, well, what can I multiply? I can multiply this equation by a number where I can eliminate my y variable. Okay, what does that mean? I'm going to multiply this whole equation by negative 2. Okay, I'm going to write it out right here underneath. So I'm multiplying every single term, okay, the 7x, the y, and the 2. Negative 2 times 7x, I get negative 14x. Negative 2 times y, that's negative 2y. Negative 2 times 2, that's negative 4. See, the equal sign, everything is still in the same place. I multiplied each one of these things by negative 2. Okay, do we see what that did? Now, when I look at these two y terms, my positive 2y, my negative 2y, now I can go through when I add these two equations together, they're going to cancel out. That's what I need. I need my y or my x term to cancel out to 0. Okay, so let's combine these equations now. I've got this 5x minus 14x. Okay, so I'm going to end up with negative 9x. I had to think about that for a second, make sure I'm not doing goofy math. Negative 9x. All right, then my y terms, trying to combine those. So positive 2y minus 2y, that's going to go to 0y. Okay, 4 minus 4, I get another 0 over here. So I know that 0y is going to cancel out. That's the whole reason I multiplied that equation. All right, so now I know, okay, awesome. 0y is gone. Now I just have this negative 9x is equal to 0. right? Again, sometimes when we get these equations where they're equal to 0, we think we've messed up, but just solve it out like normal. You're multiplying by -9, so go ahead and divide by -9. Okay, divide by -9. Those cancel out. I'm left with x is equal to 0. All right, that's half for your answer, but we want a y value as well. So you're going to plug that 0 in to one of these equations. All right, it doesn't matter which one. It could be this one, it could be this one, it could be the one that you multiplied. It doesn't matter. I'm going to do that 5x plus 2y equals 4. But again, don't get hung up on which one you choose. It doesn't matter. Okay, so 5x plus 2y is equal to 4. We're plugging in 0 for x, so 5 times 0 plus 2y is equal to 4. Okay, 5 times 0 is 0 plus 2y equals 4. You don't have to write 0. I could just say 2y is equal to 4. I'm multiplying here by 2, so I'm going to divide each side by 2, and I get y is equal to 2. Kind of looks like the approximately equal. My screen just bounced when I did that. Y is equal to 2. Okay, so for my final answer, I'm going to put the x and the y in one ordered pair. I'm going to get 0, 2. Okay, so that's what I mean when I say sometimes they're not going to be set up so they automatically just cancel out. A lot of times you are going to have to go in and multiply one of these equations so that you get something that cancels out. That's the whole it's called elimination. Sometimes we lose sight of that when we start doing a bunch of these problems. We forget what we're trying to do. We're eliminating one of these variables. All right, more examples. Let's look at one of these special cases, and then we'll get on to quote-unquote day 2, and I'm just going to leave it all as one video. Okay, so we have this x minus 4y equals 8, and then 2x minus 8y is equal to 16. So I'm trying to think, okay, what can I do so that usually you want to take whatever your plain variable is. Okay, over here I've got an x, and say, okay, what can I multiply this by so that it cancels out? So I'm looking over at the other equation. I see, okay, it's positive 2. So I'm going to multiply this whole thing. It happens to be negative 2 again. It can be anything. All right. So I see that x and 2x. I'm saying, okay, I want those to cancel out. So I'm going to multiply this whole thing by negative 2. I'm going to write it there right under that second equation. So I've got negative 2x. Negative 4y times negative 2, that's positive 8y. Okay, negative 2 times 8, that's negative 16. Okay, now I have some things that should cancel, so I'm going to go ahead and add those two equations together. All right, 2x minus 2x, that's going to get me 0x. Negative 8y plus 8y, well, that's also going to get me a 0 term. I'm going to have plus 0y now. All right, so that should be an alarm bell. This is a special case because if I eliminate both of my variables, something is up. I'm either going to have infinitely many solutions or I'm going to have no solution. It just depends on what I get here. So 16 minus 16, that is going to be 0. So let's go ahead. We can cancel out 0x. We can cancel out 0y. We know that that's just the same thing as 0. So, okay, let's just call that 0. And here on the other side, I have 0. So if I end up with 0 is equal to 0, you're always thinking, okay, when I just get number equal a number, you're trying to think, is it true or false? Okay, if it's true, then you have infinitely. Okay, infinitely many solutions. Okay, or just IMS. Again, this is for basically everything, with all these different types of equations. When you get something that's true, it's infinitely many solutions. When you get something that's false, then we're going to have no solution. So maybe let's look at number 2 and see if we get something else. All right, again, I'm looking at my plain variable, and I'm thinking, what can I multiply that by so that I can cancel it out with my other equation? I've got plain x, and I've got 4x over here. What can I multiply that equation by so that I end up eliminating it? Okay, I need -4. I want the opposite of this coefficient. All right, so I'm going to multiply the second equation here by -4. Okay, all three terms, x, -3y, +18, I'm multiplying all of those things by -4. All right, so -4 times x, I get -4x. -4 times +3y, that's going to be, sorry, I think I said -4 times -3y, I get +12y. I think I said that backwards. And then -4 times +18, and end up with -72. And yes, I had to do that on a calculator. All right, I'm just going to rewrite this equation now so we have them both together. Okay, you always want to have them kind of lined up so it's easy to see what you're doing. So I'm going to now write that 4x minus 12y is equal to -60. So I'm going to go through, I'm going to add these two equations together. I'm combining them. That's what I do with elimination method. So -4x plus 4x, I get 0x. Okay, then 12y minus 12y, I'm going to have 0y. And then -72 minus 60, looks like I get -132. All right. So 0x, 0y, those two things cancel out. They cancel out to 0. So I can rewrite that as 0 is equal to -132, right? Which I know is not true, right? So I now have to go through and say, okay, if it's not true, I know that means no solution. Okay, you can write the little x with a, 0 with a cross through it, or line through it. Okay, no solution. Okay, so just like with graphing, just like with substitution, we can have these examples where they aren't a typical just one point is your answer. Sometimes it's the same line, you have infinitely many solutions, and sometimes you have parallel lines where they don't cross at all. Right? So here's all the same thing, just kind of written out. So everything might cancel up. You end up with 0 equals 0. You know that's true. There are infinitely, I'm just going to write IMS, infinitely many solutions. Okay, it's the same line. Or if you have a false statement like that second one we just did, we have no solution. Okay, so just keep that in mind. If you wanted to break this up into 2 days, this is where I'm going to start the day 2. Okay. Even if you're not breaking into 2 days, go get a snack or something because this is a really long video. All right. But I'm going to just keep on. We're going to power through. We're going to do day 2. I'm going to put it all in one video. You can break it up however makes sense for you this week. All right. So the added difficulty that we have with the second round of equations are sometimes we can't just multiply one equation and end up eliminating. Sometimes we have to multiply both equations by something in order to get a variable eliminated. Okay, take a look at this first example here. Okay, I can't multiply 7 really by anything, or at least not by anything easy. That just gets me, that's going to cancel out with negative 5x. There's nothing I can just multiply 8y by where I can end up with 12y. I mean, I could do a fraction, I guess, but that would be some kind of gnarly math. Okay. So you want to think of, and this might be kind of a flashback to some elementary school math, the least common multiple between these two numbers. Okay, so let's say I wanted to eliminate my y's. Okay, I want to think, what's the smallest thing I can multiply 12 by and multiply 8 by where they have a number in common? I want their coefficient to be the same number, just with different signs, so I can go through and cancel them out. Okay, so think about some multiples of 12. Okay, some people kind of struggle with this because they can't think of the multiples super easily, so they're thinking, I don't know what number I should use. So a lot of times what I like to do, just pick one of the variables. Okay, you've got two coefficients. You've got 12 and you've got 8. Okay, so for 12, just think of some multiples. 12, 24, 36, 48. You could keep going, but let's start with that. 8, you've got 8, 16, 24, 32. Okay, let's start there, and we can see, oh, awesome. I have a multiple in common. I've got 24 for both 12 and 8. That's what we're looking for. That's what I mean. We need to find a certain value that I can get from 12 and I can get from 8. Okay, so think for a second. You have to multiply 12. Okay, so this first equation, I have to multiply that by 2 in order to get 24. And I have to multiply 8. I have to multiply the second equation by 3 in order to get 24. Okay, so that's our number we're going to have in common. All right, so let's go ahead and do that. I've got the first equation I'm going to multiply by 2. So I'm going to have each one of these terms, 7x, negative 12y, negative 22. I'm multiplying each one by 2. Okay, so 2 times 7x, that's going to be 14x. 2 times negative 12y, that's going to get me negative 24y. And then 2 times negative 22, that's going to be negative 44. Okay, so when I multiplied by 2, I ended up with this equation right here. And I'm going to do the same thing with this second equation, but I'm going to multiply that one by 3 because the whole goal of kind of looking at these different multiples was seeing, okay, I have to multiply this by 3. We're going to cancel out my y values. Okay, so I'm going to multiply by 3. I'm multiplying each term by 3. Don't just multiply the 8y by 3. Okay, you have to multiply everything in this equation by 3. So 3 times, that's my eraser. 3 times negative 5x, that's going to be negative 15x. Okay, 3 times 8y, that's going to be positive 24y. And then 3 times 14, gotta think for a second. 3 times 15 is 45, so that's going to be 42. All right, so now I can add together these two equations. All right, so I'm going to add all my like terms together. 14x minus 15x gets me negative x. I could call it negative 1x if I really wanted to, but I don't. So I'm going to leave it as negative x. All right, negative 24y plus 24y, that's what we wanted this whole time. We wanted that to go to 0y. Yeah, that was our goal. Doing all that multiplication was so I could cancel out that y. Okay, negative 44 plus 42, well, that's going to get me negative 2. All right, so first off, I know I can get rid of that 0y. I'm canceling it out. I'm eliminating it. So I'm left with negative x is equal to negative 2. And I want to get rid of that negative sign, so I'm going to divide that by negative 1. and divide this here by -1 as well. Okay, so those negatives cancel out. I'm left with x is equal to +2. All right, I'm halfway there, but I need to now plug in this x so I can find my y value. Alrighty, so I have this -5x plus 8y is equal to 14. I could have picked any of these equations. I could have picked this one. I could have picked one of the ones that I had multiplied. I just picked one at random. Okay, I usually just pick whichever one looks the easiest. All right, so -5x, so -5 times 2 plus 8y is equal to 14. Okay, -5 times 2, I get -10 plus 8y is equal to 14. I know I can add 10 to both sides. I want that -10 to go away, so I'm going to add 10. So I get 8y is equal to 24. Okay, and I'm multiplying by 8, so I'm going to divide by 8. Right, so these 8s are going to cancel out, so I get y is equal to 3. Okay, x is equal to 2, y is equal to 3. I know that my ordered pair, okay, that's always our x, y point. I'm going to have 2, 3 for this one. 2, 3 is the point where these two lines intersect. Right? That's really the gist of it. I'm going to show one more example, right? Because I think these are really tough for some people. I'm gonna make sure that we have. There's more special cases for this one. I'm not going to do special cases again. It's the same as that we just looked at. Okay, same idea. If everything cancels out and you have a true statement, it's infinitely many. If it cancels out and you get a false statement, then you end up with no solution. So I'm going to look at just one more that where we have to multiply both of these equations. Okay, I'm going to show you kind of another way to look at it, because for some people the least common multiple thing, they like break out into a cold sweat when they hear the words least common multiple, and they're like, I can't do this. I never figured it out in elementary school. I don't know how to do it. Okay, kind of the cheat code here is to look at the two equations. I'm going to look at A here. You're going to look at your two equations, and first off, you want to see, okay, do I have one that's positive and one that's negative? So one variable where one is positive, one is negative, and we have that. Okay, I've got a positive 2x and a negative 5x. So that's good. If everything was all the same sign, you'd have to multiply one of them by a negative number, because if you just have like a positive 5x and a positive 5x, they're not going to cancel out. You're going to get 10x. So we always need to make sure that you have a negative and a positive. All right? And instead of going through the whole least common multiple thing, you're just going to say, okay, well, I know if I multiply this equation, if I multiply that equation by this coefficient, I'm going to get something that eliminates. Okay, so if I multiply this top equation by 5, and if I multiply this bottom equation by this coefficient, so if I multiply that by 2, it may not be the least common multiple, but I know it's going to be a common multiple. Okay, what I mean by that is if I just multiply each equation by the opposite coefficient, it may not be the absolute nicest numbers, but it's always going to work. Okay, so for some people, it's too much work to figure out the least common multiple. They like go into hives when I say those words. Don't worry about it. If that doesn't make sense to you, just take the opposite coefficient and multiply it by that. Okay, so I've got over here this first one, I'm multiplying everything by 5. Everything in this first equation by 5, so I've got 5 times 2x, I get 10x. Okay, 5 times 3y, I get 15y. 5 times -1, I get -5. Okay, same thing with 2. I'm multiplying each one of these terms by 2. So 2 times negative 5x, I get negative 10x. Awesome. I can see those x terms are going to cancel out. 2 times 5y, I'm going to have 10y. And then 2 times 15, I'm going to have 30. I'm just making sure I didn't make any silly math mistakes because I've been talking for a long time. Okay, I don't think I did. I'm going to add my two equations together. Okay, 10x minus 10x I know is 0x. 15y plus 10y, that gets me 25y. And then negative 5 plus 30 is also 25. Okay, I know that 0x gets canceled out. I don't care about it. I'm just left with 25y is equal to 25. Sorry, that's my Apple Watch. All right, 25y equals 25. I am multiplying by 25, so I'm going to divide by 25 to get rid of that. Okay, dividing by 25. Okay, so I end up with my 25 canceled out. So I should end up with just y is equal to 25 over 25 is 1. I am almost there. I want to plug that y equals 1 into one random equation. Apparently, I should put my watch on mute when I record these. All right, so I'm going to plug it into that second one. Negative 5x plus 5y is equal to 15. Okay, so I'm going to plug in y equals 1 here for y. Okay, negative 5x plus 5 times 1 is equal to 15. Okay, negative 5x. Okay, 5 times 1 is 5 is equal to 15. I want to get rid of my 5, so I'm going to subtract and subtract by 5. So negative 5x is equal to 10. I'm going to divide each side by negative 5. Okay, that cancels, so I'm left with x is equal to negative 2. Okay, y is 1 and x is negative 2. I know I need to put that in an ordered pair. So negative 2 and 1. Right? That is the point where these two lines intersect. All right? If you have sat and you've watched this video all in one sitting, you are a trooper. This is super long. I never want to make another video this long again. This took forever. All right? But again, hopefully you split it into a couple days. All right? I know this week is crazy. I know transitioning back to hybrid learning is crazy. Just stick it out. I'm so excited to actually see you guys in person again. I am sick of just talking to a computer screen, so I'm very excited. I will see you guys this week. I hope you have a great day.